So in this unit, we've talked about different types of graphs that can represent different types of data. We've talked about how we can use Microsoft Excel to actually graph them, and then be given graphs and be able to pull information from it, no matter what the graph is, whether it's a circle graph or a bar graph or a histogram or a line graph. Really, I think sort of moving down the road towards some kind of final exam or something like that, or final project, still sort of haven't decided yet. But if we went with an exam, the only thing I would expect out of you guys from this would be how to interpret. So if I give you a graph and ask you questions from it, much like the short answer on that last assignment, and you should be able to tell the difference between discrete and continuous data, and tell in a situation like, say, if you're making a line graph, what's an independent variable, what's the dependent variable in a situation. That's sort of what you'll need. You guys have already been assessed on how well you can use Microsoft Excel. I don't need to do it again, okay? But interpretation we can always look at. So your interpretation actually, I mean, a lot of the times, it's just looking at the graph and pulling the factual information off the graph, which is those questions like I asked you in that last hand-in assignment. You know, look, so if I said to you, what was the temperature change in 1870 according to this graph? 0. That's a fact from the graph. Okay, so that's one thing that you can represent, but you can also throw your opinions in there, as long as they're supported by what's happening in the graph. And everybody sort of has different interpretations or different opinions. So like if I give you this graph from 1850 to 1990, the temperature change in degrees Celsius of Earth, tell me something about this graph. Just, yep.
Well, as the Industrial Revolution happened, the temperature changed.
So the Industrial Revolution happening in the 1800s increased the temperature in the Earth. Okay. Yeah. What else? You don't necessarily have to look at the whole graph. You could look at the whole graph. Has the temperature generally gone up? Yes, except 1950 to 1970, right? It went down. So that's another interpretation you could make. And it's correct, because it did. I wonder why, though. Why would it have gone down from 1950 to 1970? It's a good question. I guess, I mean, the only thing I can think of is like the 1950s sort of generally was a wealthy time. And that moved into the 60s. And then in the 70s, things became tougher on people. Inflation spiked and things like that. So, you know, perhaps there was some kind of stop in, say, the number of factories being built, or there was some kind of plateau of the number of cars on the road, so that it kind of leveled the temperature here and then actually dropped it there. Or maybe it was some other factor, something to do with the Earth itself. Okay. But the point I'm trying to get across is, you know, everybody can have different interpretations. So this is an opinion question. And like you hopefully learned in several of your other courses, language-based, if you're going to state an opinion, you got to be able to back it up. You know, so you could, like I said, you could say, well, over this whole time, temperature has increased from 1850 to 1990. Or you could say it really increased, or there was a sharp spike from 1910 to 1930 and then 1970 to 1990. So what was going on 1910 to 1930? Well, that was the First World War. So that could have been a big spike in production, big spike in machinery being used, which could affect the environment, which could affect the temperature, right? And like I said, everybody sort of has different interpretations. So here's a circle graph. And this is the hair color of kids at a certain daycare. Now, you want to be careful sometimes how you look at graphs, and that's sort of the another part of this lesson I'd like you to focus on is, okay, don't look at the numbers, just look at the percentages. What would you tell me? What's the first thing that pops into your head? Most of them have dark hair, or a little over half have dark hair, right? Or we could say a third of them are blondes. Or we could say almost half have red hair and blonde hair, okay? Now, we got to be careful, though, when we look at these things, because we can't sort of apply that to every daycare. Because look at the number of kids we're dealing with. We're dealing with 11 kids. That's not a big group, okay? Because we could easily walk into a daycare 5 blocks down the road and see 6 with blonde hair, 4 with dark, and 1 with red. And now all of a sudden we're making a different conclusion. So not only with circle graphs, you want to look at the percentages, you can draw conclusions from there. But if you're given the numbers, you want to be careful how you draw some conclusions. I mean, yeah, you can say at this daycare, here's what's happening. So yeah, just a couple of things, how you want to interpret it. And finally, and we talked about this before, how can we manipulate data? And we can use bar graphs, and we can use any type of graph to manipulate data. If we want to make something, we want to show a certain thing that puts us in a favorable light, especially a business. How can we show the data so that it makes us either look good or it makes us look not bad? We don't want to do something that makes us look bad. So here, so yeah, you can read different graphs differently. So you can also draw different conclusions using the same data, depending on how you scale everything. It's the scale that really does it. The vertical axis, changing things. And we saw that when we talked about bar graph. I believe when we talked about bar graphs, we had examples of bad bar graphs. But here, so here we have the following chart lists the annual sales of What's It widget company. A widget is just a generic term for an object. That's actually what a widget is. Like if we want to just make up an object, call it a widget. So these are the sales from 2004 to 2008. You can see just by looking at the numbers that, yeah, it's climbing. But how it climbs, we can manipulate. So if we just graph it using a scale, like a good scale, starting at 0, we can see that there's a gradual increase. Okay? This would sort of be this graph would be considered out of the three that we're going to look at the most honest? The most honest representation. We start at 0, we use a good vertical scale, and we see there's a gradual increase. Okay? But if we start fiddling around with the scale, the vertical scale. So let's say the president of the company wants to make it look like our sales are increasing even more. Like the first bar graph, yeah, it showed it was increasing, but gradual. He wants it to look better. He wants it to look sharper. So what do? We change the vertical scale. We don't start from 0. We start from a number that's closest to the lowest value. So the vertical axis doesn't start at 0. But at a value close to the lowest data value. And then it finishes by the same reasoning. The highest one is close to the highest data value as well. That will give us a more exaggerated increase or decrease, in this case, increase. So looking at this, somebody will say, wow, that's a pretty significant increase. But really, when we looked at the other one, we weren't saying that. But what if president of a different widget company has to do a presentation on their sales, as well as the sales of other widget companies that they compete with, and they want to make the What's It widget company, they want to make their increase look as small as possible, almost like it's not even increasing at all. To say that, yeah, our sales have gone down a little bit, but look at our competitors. They're basically staying the same, so we're not that bad. Whereas if you looked at the original one, the A, the most honest one, we could see that no, there was an increase. There was a definite increase. It was gradual, but it was definite. Okay. So how do you create a bar graph using this? Make your vertical scale range wider. Okay. So make the vertical axis scale range, I won't say wider, larger. Start at 0, but instead of finishing, say, at 200,000, a little bit above the highest value in the data, go 300 or 400 or 500. The more you do it, the bigger this is, the smaller this increase will look. Now, we only looked at certain types of graphs, but I wonder if I have this website. Maybe I don't. I don't know if I have it bookmarked. I have it in Drago. Let me see. Let me just. I had it. Okay, let's try this. Yeah, the New York Times puts it out. Like all sorts of, I mean, you want to talk about all sorts of different types of graphs. This is a good website to look at all sorts of different types. Like, so what they do is they give you one of these and they ask you like, okay, what's going on? We got some arrows. Some arrows are different colors. Some arrows are thicker than others. That may seem to correspond to the percentages that were given here. We got something in the middle. What's this in the middle? Yeah, it's Russia. So it's what's happening after they invaded Ukraine. So you can see, was there more or less going to Russia after the invasion? And you can see that some countries like Brazil and China, and I wonder what this country would be down here. Turkey. That the trade volume went up, whereas other countries like South Korea, UK, United States, Sweden, what we would consider democratic countries, went down. Okay. Although, I mean, there are some purple ones that are like Belgium and the Netherlands are democratic countries, so is Spain, but they actually went up. But it's an interesting website because you can they have all sorts of, like here's kind of like a yeah, things like this going on. Looks like it has something to do. What do you think this might have to do with? Yeah, injuries. Because we see sports and we see different parts of the body. So, but it's an interesting site because you see the graph, you're not really given any information about it. You may be given you should be given enough information to figure out sort of what's going on. But it's kind of cool to look at. Okay.